Okay, so I thought I would read this out loud so you could follow along with me reading. Thought it might be easier than just having to read something you could listen to. I know some of you are auditory learners. I know I am. So I figured this might help you. If you hear some weird noises in the background, Colin is playing, so sorry about that, but I figured this would help you. If you're listening, I do want you to follow along with the reading. So this reading is going to be all about magnetism. We're going to talk about how magnetism is a force and there's a field associated with it. This reading is from CPUP, but I've modified a lot of things, added some things in from other sources, cut some things out that didn't need to be in there to make it a little easier. Here we go. Magnetism. This is something you have definitely experienced in your life, but probably don't know much about. Perhaps. I don't know if you learned in elementary school. Magnets have two poles, not poles. Sorry, had to put that joke in there. A pole is a highly charged region of the magnet. These are often called north and south poles. So if you see in this picture, we have the north pole here and we have the south pole here. Opposite charged poles attract, north and south, and same charged poles repel, north and north, also south and south. Recall that this is unlike gravity because gravity is only attractive. Gravity does not repel. Magnets exhibit forces on other magnets. So they pull. If there's opposite poles, they're being pulled together. And pushes happen when they're oppositely charged and they're trying to repel. Here's an example where push happens and pull happens. So a lot of people might wonder, can you cut the magnet in half so then it would only be a north and a south, like one north and one south? No, as soon as you cut that magnet in half, you're just going to have a smaller magnet with north and south. So you can't just have a north pole, you can't just have a south pole, always has to be a combination of both. So did you know that Earth is a giant magnet? I bet you knew that Earth has a north pole and a south pole, but there's actually a north pole and a magnetic north pole. So these two poles are roughly, oops, I forgot to finish this. Okay, I fixed it. So there's a north pole and a magnetic north pole. These poles are actually roughly 285 miles apart. This amount changes over time, which that's one of my fun facts coming up, so you can kind of see how the magnetic pole has changed over time. So when you are using a compass, you are using Earth's magnetic field. The needle in the compass is actually a tiny magnet, and it's being attracted to Earth's north pole, so you can align it with the north and see what direction you're traveling in. Okay, so just as there was gravitational fields, there's also magnetic fields. You can't see them, but there's a couple things you can do to see the evidence of these fields. So this is where I want you to watch the videos. If you already watched them, that's fine. You would already know the two ways to see. One way is with iron filings, and that is in video number 1. And then I used a compass, and I actually did the lab that you were going to do in class. So you can also use a compass and a magnet to see the fields and map out the fields. So watch these two videos to make sure you can see what this looks like. By the way, it's a really good thing that Earth has a magnetic field around us, because this magnetic field blocks some radiation from outer space with solar flares and whatnot. So it makes it possible for us to have life on Earth, actually, because that would be bad if the radiation got to Earth. So there are different types of magnets. I want to talk about that briefly. Permanent magnets are magnets that will always be magnetic. These are things that you know, like fridge magnets, toys, Collins trains. Those are all always going to be a magnet. But you can also make a temporary magnet. If you put certain types of objects in a very strong magnetic field, you can make it into a temporary magnet. It's called a temporary magnet because eventually it's going to lose all its magnetism. Doesn't stay a magnet forever, but you can make objects that are not usually magnetic into magnets. You can also use an electric field, an electric current to make a magnet. So I'm going to wait and do that with our electricity unit, but we did that lab too. Mr. Pohl and I did that lab too. Oh, hi Colin. So real world application. I wonder if any of you have ever had an MRI. MRI stands for magnetic resonance imaging. And what they do is they take a strong magnetic field and then they take pictures of the magnetic alignment of cells in your body so you can see if you have an injury, what's going on with that. So that's pretty cool. So now we're on to the questions. So I'm just going to read the questions and then it's up to you to type in the answers. So I want you to tell me, how are gravitational fields, what we learned about last week, how are they similar to magnetic fields? How are gravitational fields different from magnetic fields? And then I'm just curious because I haven't taught this unit before. So can you tell me something you already knew that was represented in the video? Maybe you did some stuff in elementary school around magnetism. I just don't know. I've never taught it before. And then tell me something that you learned or multiple things that you learned from this reading and video thing. Also, if this was helpful, can you send me an email and let me know? Because if it's not helpful, I won't do it again. And sorry for Colin's noise in the background. Okay, have a good day.